Just for clarification, the inverse of the 1 over x squared function turns out not to be a function, it's an inverse relation. If we write the table for the inverse square function, a reciprocal square function, here's the table. Now I wrote down the table carelessly. I wrote 4, 1, 1/4, 1/4, 1/4 without thinking it through. I know better, but I wrote it down wrong. So it was written down wrong and led to a graph that was erased here. But if it's written down right and then we invert it by switching the columns and graph it, we get these 3 points here, these 3 points here, and here's our graph. And clearly this is not a function, it's an inverse relation. Now, to get an inverse function, we restrict the domain. Okay, we restrict the domain of the reciprocal square function to the interval 1/2, 2. So 1/2 is maybe here, 2 is here, and here's our reciprocal square function. The inverse relation, okay, to the entire reciprocal square function would be this curve and this curve, as we saw. And if we restrict the domain here, then we only have positive values of x. And when we switch the x and y coordinates, that's only going to give us positive values of y, and it's going to give us this curve, this part of the curve. And this part of the curve is a function. Okay, so by restricting the domain, we get a function. Similarly, if we have the basic squaring function, if we draw the inverse relation, it's going to be a parabola over here like this, and it's not going to pass the vertical line test. Now you can actually do that. It's very easy to switch the columns, switch the numbers in the column, and graph the table that you get. And you're going to get that just the same way we got this graph here with the 2 branches. Okay? What we do in the case of the x squared function, if we want to do an inverse function, we restrict the domain to only non-negative numbers, 0 and positive numbers. Now for the basic function, we just go from 0 to 2 for the basic extended function. The domain is going to be from 0 to 2. The range would, of course, be from 0 to 4. Then when we switch the columns, the domain of the x squared function becomes the range of the inverse function, and the range of the squared function becomes the domain of the inverse function. If you plot the points, you're going to see that they lie on this curve. And this curve should be familiar to you from the very first assignments. This curve is the square root curve. Okay, the inverse of the squaring function, if restricted to the domain of non-negative numbers, is going to be the square root function. Okay. Now, algebraically, you get an inverse relation by switching the x and y coordinates of the original function. Okay, so if you have y equals 1 over x squared, you switch, you make the x into a y, you make the y into an x, and you get the inverse relation because, of course, when you switch the columns, you're switching the roles of x and y. So we do the same thing with the formula for the function. And then if we want to get the function, we solve for y. And in this case, if you solve for y, you're going to multiply both sides by y squared. That's going to give you xy squared equals 1. We're going to get x y squared equals 1. And that then leads to y squared equals 1 over x, which we have here. And then your solution is that y is a square root of plus or minus the square root of 1 over x, either plus the square root of 1 over x or negative square root of 1 over x. Now, if we restrict the domain so that the x values here are always positive, then the y values here are always going to be positive when we switch the roles of the x and y to get the inverse function, and we'll only have this. So if we restrict x here to be only positive, then the y's here will only be positive, and we won't include this. And this will be our standard inverse function of the reciprocal square function. Okay, I do believe that's it. For some reason, Zoom didn't pick up the last part of class, so that should give you the content.